All right, so on this last problem, they're asking you to come up with a way of finding the wavelength. And what we developed in class last week was a relationship between this triangle here, y and L. This side here compared to this side was very similar to the wavelength of light going through D. And we gave that proof on the interactive, or the little sheet that had the overlapping interference patterns on it. So the summary of all that is that we get this relationship that says y is to L as lambda is to D. And what y over L could be written as is really the tangent of an angle. And so I could say the tangent of the angle theta is equal to lambda over D. And there's what we call a small angle approximation that we get away with that says when you talk about these smaller angles, the tangent of theta is very, very close to the sine of theta. So technically like that. And so what this comes down to is whichever spread we used, whether it be this first maxima, this would be M1, this would be M2, this would be M0. Whichever bright spot we use to find that, we can summarize that finally by saying the sine of theta times D, just multiply this on each side. And remember, tangent theta is basically the same thing as sine theta for these problems. That's why we get away with this is an approximation and not an equality. Whoops. And so now as I'm looking back, I got to change all these to squiggly equals because it's not perfectly equal. So I got d sine theta equals lambda. And then where the m comes in is whichever bright spot you measured out to. Remember back on our picture that the next bright spot over, this one here, was off by 2 wavelengths. And you get to the next one, it's off by 3 wavelengths. And so every bright spot you get to is going to be off by 1 full wavelength. And that's why it constructs back on itself again. So to see that, if you had like a wave that was in phase there, and we have another one that starts 1 wavelength over, 1 full wavelength off, these would be lined up and you get construction. If you move them 2 wavelengths off, and let's say start something like here, you still get them to be in phase. So every m value over, whether it be 1, 2, 3, etc., is just a multiple of wavelengths off. So if I just use that first one, then this is my equation. And I don't have to do anything else. So d sine theta equals lambda. That's all I need to do for that. But if I were to use, let's say, like the second or third bright spot over, I'd have to substitute in m for that, and that would be your full equation. So d sine theta equals m lambda, because as you pick further and further bright spots over, you will get more and more multiples of lambda that they are off by. Hope that helps. If you got questions, please reach out on Google Chat.